All right, we're going to get started, so if you can please take a seat. Thank you very much. I'm thrilled to announce our next speaker, Patrick Wardle from Synack. He is going to talk about getting duped, piggybacking on webcam streams recordings. So looking forward to this. Thank you.
Thanks. So yeah, let's talk about surreptitiously recording users. And you might be wondering why I'm talking about this. Honestly, I used to work at the NSA, and I guess old habits kind of die hard. But no, seriously, I think this is an attack that users and security vendors should be aware of. So yeah, my name is Patrick Wardle. I've worked at a variety of acronymed places. I'm currently the director of R&D at Synack. So Synack does crowdsourced vulnerability discovery. Basically, we used vetted security researchers and technology to basically pen test or look for vulnerabilities in our customers' web apps, mobile apps, IoT devices, and network endpoints. So if you're interested in a bug bounty program, definitely check out Synack. All right, so what are we going to be talking today? We're going to start off by looking at some webcam background concepts, talk about some privacy and security issues there. We're then going to jump in and look at some recent Mac malware specimens that are webcam aware. And what I mean by that is that they would try to spy and record users once they got on an infected target. We're then going to talk about a new attack or capability that would allow malware to record the user while the webcam is legitimately in use without detection. And then finally, we'll spend some time discussing methods to detect this capability, detect this attack, and talk about a free tool I'm releasing that can hopefully ensure Mac users are protected against this. Now, I do want to stress what this talk is not about. I don't want to overhype things. Security talks sometimes do that. So it's really not about bypassing the LED indicator light directly. And it's also not about any exploit or vulnerability per se. Rather, we're going to talk about abusing legitimate functionality of the operating system to record audio and video while the webcam is legitimately in use without the user being able to notice this. OK, so let's start by talking about some background concepts. Now, I'm sure we're all security and antivirus researchers here. We know that one of the most insidious actions that malware can take is recording a user. Right? In terms of security, privacy, if there's a piece of malware that's able to capture the user and see what they're doing and saying, that's kind of, at least to me, the most scary or one of the worst things it can do. And unfortunately, hackers are doing this, Mac malware is doing this, and nation states are supposedly doing this as well. And so it's definitely something of a concern. And so what can we do to thwart this? Well, the FBI, the same guys that are trying to hack into our iPhones, tell us that we can simply just cover your webcam with tape. And that's actually a pretty good low-tech solution. Now, when people talk about malware and webcam and hacking webcams and recording the users, really always comes down to the LED indicator light. Luckily for users, not so much for the malware, anytime the webcam is activated, the LED indicator light comes on. And it's actually designed in a way that's very, very difficult to disable. Now, in the past, even on Macs, this has been successfully disabled. Some researchers from the Johns Hopkins University in 2008 showed that they were basically able to reprogram the firmware on the chip that had the LED indicator light and basically then record the user without the light going off. But since then, Apple has made great strides and really done a good job securing that, right? It's basically implemented in hardware on a separate chip, kind of isolated from the operating system. So unless you have physical access or some incredible exploit, you're really not going to be able to disable that LED indicator light. So shortly, we're going to look at some malware samples that, on Mac, access and abuse the webcam to record the users, and then also talk about an attack that we can leverage. But I briefly wanted to talk about programmatically, at least first initially from a conceptual point of view, how one accesses the webcam on Mac OS X. So programmatically, turns out it's actually pretty easy to do. There's a foundation framework called AV Foundation that Apple provides, and it makes it really easy to do a variety of tasks. So for example, you can very easily enumerate all attached devices on the system. So you can find the webcam, the mic, and whatnot. And then once you have reference to those devices, you can very easily activate them and start recording off them. Now, of course, anytime you do this, the LED indicator light is going to go off, as long as you're the initial process initiating that. Now, you might be wondering if there's any access constraints that are placed on the webcam. And the short answer is no. But turns out if you are a sandboxed application, you have to have a specific entitlement that says you're going to use the camera. So entitlements are simply capabilities that the binary can convey about itself. So when you're building an application that's going to go into the Mac App Store, if you want to use the webcam, you have to basically tell the compiler that you're going to use this. So specifically, you add the com.apple.security.device.camera entitlement. Now, this is easy. You can add this yourself while you're building that application. And then when you submit it to the App Store, I'm guessing it's going to be approved. I haven't seen anything indicating that Apple will block an application if it has that. I mean, we've all seen malware end up in the iOS App Store and the Mac App Store, so I doubt Apple's going to block that. You know, maybe if you're like a calculator app, they might ask you, hey, why are you using the webcam? But again, this is only for sandboxed applications. So if you're sandboxed and you don't have this entitlement, though, when you go to access the webcam, the operating system is going to deny you. But again, you can add this entitlement yourself, and Apple will most likely approve it. Now, if you're not a sandboxed application, meaning you're distributed outside the Mac App Store, which a lot of apps still are based on the constraints of the Mac App Store, you don't need any entitlement, you don't need root, you don't need anything. So pretty much any code that's running on the Mac can access the webcam with no authorization issues. OK, so that was some general background concepts of webcams. Now let's look at some Mac malware samples that try to record the user by activating and leveraging the recording capabilities of the built-in webcam. Now, I want to point out that these malware samples are really not that sophisticated in the sense that they all arbitrarily record kind of whenever they think they should, which means that the LED indicator light is going to come on. And this, in my opinion, is kind of amateurish and a dead giveaway, right? If you're sitting at your desk and all of a sudden the webcam light goes on, like, that's a huge sign that your computer's probably hacked. So the first piece of malware I want to mention is Hacking Team's Mac Implant called Crisis. It has a myriad of features for gathering intelligence. It's really all about surveillance. So that obviously means audio and video capabilities as well. So when Hacking Team got hacked, the source code for this got released, or leaked, rather. And which is great. As malware analysts, we usually only have binaries to reverse engineer. So anytime source code gets released for malware, we're stoked. So whoever hacked Hacking Team, good job. I don't know if officially I could say that, but made my life easier. So anyways, if we look at the slide, look at the source code, we can see this is the code that was responsible for recording off the webcam. Turns out that they used a framework called Qt-Kit, which is kind of a precursor to AV Foundation. So it's an Apple framework. It's now deprecated. But it basically provided the same API interfaces as AV Foundation. So again, very easy to find the webcam and start recording off this. Again, of course, the LED indicator light would go on, likely alerting a user of the presence of the malware. A more recent sample that was discovered in July by Bitdefender is Eleanor. So this was a Tor-based backdoor that also contained a variety of open source tools that kind of extended the functionality of the malware. This is fairly common. We sometimes see malware authors packaging up open source or free utilities, allows them to kind of extend the functionality without having to implement the logic themselves. So in terms of the video capture capability, Eleanor shipped with a utility called Waka. Now, Waka is open source, available on source code. You can download it, run the precompiled binaries, and it will allow you to capture or record the user from the command line. So this piece of malware had this utility, and so what the attackers could do is simply execute it and begin recording the user. Again, the LED indicator light would go on. Finally, we've got OSXMoles, which was discovered just last month by Kaspersky. It's a cross-platform backdoor. It's got fairly standard backdoor features. You can run arbitrary commands, exfiltrate data, but it also had audio and video capabilities. So if we look at the disassembly for this malware, we can see that it's using the Qt framework, or Qt framework to do its recording. Qt framework is a cross-platform framework, which makes sense because this is a cross-platform piece of malware. Now, if you dig into the specifics of this framework, obviously the framework's going to have some OS-specific code. So if you look at Qt's webcam recording code, on Mac it just calls into Apple's AV Foundation. So it just provides an extra layer of abstraction so cross-platform code can compile. And again, the LED indicator light would go on. So that was some recent Mac malware trends. Hopefully that illustrated that there's Mac malware, and that such Mac malware, even the most recent samples, are very interested in recording the user, using the webcam and the mic. Luckily, again, the LED light always goes on. So again, that's kind of a dead giveaway for the malware. So I now want to talk about a scenario, a capability, an attack, where such malware could simply wait until the user is legitimately using their webcam and then piggyback onto that session to record the user without any detection. Now, the first thing is I think it's important to make the observation that Mac users do use their webcams. Generally, they're not going to be recording themselves, but as we'll see, that's not really a prerequisite for this attack. So, what do Mac users use their webcams for? Well, business, right? So CEOs will, maybe talk to the board about earnings of a company, have a go-to meeting. R&D employees, if you're remote or your team is, across the world, you might have a Google Hangout where you're discussing new R&D, new IP, that kind of stuff. If you're a journalist, you're probably Skyping with some sources, or if you're a security researcher, you might be, FaceTiming with a security team discussing the details of a zero-day vulnerability that you found. And if you're just a normal Mac user, you might be using FaceTime to have an intimate FaceTime session, with a partner. On any given week, I really do all of these. Well, besides the FaceTime one. I'm talking with my company in California, chatting with Apple's security team, talking to maybe journalists or the R&D team. So yeah. And the other observation about these sessions are, these are really the most, in my opinion, interesting things that malware, nation state or cyber criminal malware should be recording anyways. Like, if you're recording me the entire day, you're going to see me picking my nose, petting my dog, cursing at the computer when my code doesn't compile. That's really not that interesting. But when I'm having these meetings or these discussions, that's kind of the more sensitive things that the malware probably wants to be recording anyways. So conceptually, what we, or the malware, want to do is fairly simple. So we basically are going to wait until the user initiates a legitimate session. This could be, FaceTime session, Skype, Google Hangout, GoToMeeting, anything that activates the webcam. And then when the malware detects this, it's going to simply begin recording. And then once the recording is done, it can exfiltrate that to an attacker. We'll see that this attack doesn't require root to pull off. Also, the user doesn't have to be recording themselves, just using the webcam in any capacity. And since the LED light is already on, there's no subsequent indication that the malware has piggybacked into this stream and now is actively recording the local user. So let's now take a look at step number 2, because that's really the meat of the attack. So the first thing the malware needs to do is find or enumerate the camera and mic. So for here, we'll just focus on the camera. So again, if we use Apple's AV Foundation, turns out this is really easy to do. Basically, you invoke the AV capture class method, specifically the devices with media type method, and this will return an array of attached devices, for example, cameras. You can then iterate through all of these, looking for the default one, or if you're looking for one that has a specific vendor ID or name, you can match on that as well. So when you run this, for example, on a laptop, you're probably only going to find one, which is the built-in camera. You can see it's the Apple FaceTime HD camera, and that's how Apple refers to the camera that's built into MacBook Airs, MacBook Pros, and whatnot. So now we have a reference to the webcam. What we want to do is register for notifications. And specifically, we want to register for the webcam was activated notification. So it turns out there's a notification you can register for, and it will be delivered to you by the operating system anytime the webcam is either activated or deactivated. And we'll show in a second how we can determine which state the notification was delivered to us for. So you do this by invoking the CMIO object add property listener block method. And this takes a variety of parameters. The first parameter is a connection ID, and this is kind of a unique identifier for the device that you want to get notifications for. So for example, the built-in webcam. Now this is a private property of the device, but luckily in Objective-C you can pretty easily access private methods or private members of an object. So we can basically send a selector method to the webcam object we have, and it'll return to us its connection ID, even though that's a private, somewhat inaccessible member. The next parameter is a property structure, and this allows us to tell the system what notification we're interested in. Again, we're going to tell it we're interested in the notification that occurs when the camera is either activated or deactivated. And then finally, you pass a callback block. This is just a chunk of code that will be executed by the operating system whenever the notification is delivered. So now we've registered our notification handler. Anytime the webcam is activated or deactivated by the user, for example, when they start FaceTime, Skype, GoToMeeting, whatever, the operating system will invoke our code with this notification. So now we need to determine if the notification was delivered because the webcam was activated or deactivated. So we can do this by calling the CMIO object get property data function. Basically, we're going to query the webcam and get its property. So we pass in a parameter basically saying we're interested in its state, whether it's on or off. And this will return to us a 0 or 1 if the camera is off, or 1 if it's on. So if it's off, we don't really care. But if it's on, this is our trigger event that says, OK, we should start recording, because the user has started a legitimate video session, and the LED indicator light is now active. So now we know the user has initialized or kicked off a legitimate video session, so we can start recording. Now, the reason this capability, this attack, works is because on modern Macs, the webcam is a shared resource. This means you can FaceTime and Skype at the same time, or you can run a Google Hangout and load Photo Booth and take pictures of yourself, at the same time. There's nothing to say that once one process has an access to the webcam, nothing else can access this. From a usability point of view, that makes sense. So how do you do the actual recording? Well, we can just use Apple's AV Foundation APIs. And as you can see on the slide, it's really only about 6 or 7 lines of code. It's really very easy. Basically, what you do is you create a capture session, and then you specify an input and an output. The input will be the webcam that we enumerated earlier, and then the output can be a memory buffer or a file if you want to record to a file. So once you have that all set up, you simply call start running and then start recording to output file. And then this will start streaming frames off the webcam to the file. Now, another important thing is we also want to know when we should stop recording. Because if the malware just kept recording indiscriminately, if the user ended their legitimate session and the malware was still recording, the LED indicator light would remain on. And that would, again, be kind of a suspicious indicator, right? If you were having a FaceTime session or you were Skyping and then you exited Skype and the light was still on, I mean, you might think something weird with your computer was going on, but you also might think that, there was something suspicious as well. So we'll talk about a minute how we can identify who, that is, what process or task is using the webcam, for example, Skype or FaceTime. But for now, let's assume that we have identified that. We can say, OK, the user started a legitimate session, and we know that FaceTime was the process or the application that started that. What we can then do is register for another notification, and this will tell the operating system to invoke us when that application exits. So you can do that in code via the NS workspace did terminate application notification. Again, this will get invoked, or you'll get called back anytime any application on the system exits or terminates. And the notification includes information about that app. For example, its PID, its path name, and whatnot. So what we can do in this notification code is just do a stir compare, basically, to see what application exits. And if it's calculator, we can say, oh, that's fine, let's keep recording. But if it's the application that initially kicked off the webcam session, FaceTime, Skype, et cetera, we know we should stop recording so the webcam light doesn't stay on. All right, so from the malware's point of view, this is kind of a nice, interesting, unique attack, or rather capability. First, it's Apple approved. And what I mean by this, it's leveraging legitimate functionality of the operating system. Again, the webcam is a shared resource. We're not really doing anything malicious per se. We're basically just waiting till the webcam is activated and then surreptitiously hopping on and recording the user. From the operating system point of view, there's nothing wrong. We're not exploiting any vulnerabilities. This isn't malicious logic or what. So this means it's going to be hard to patch. The other thing is you don't need root to do this attack. Again, nice. So any malware that's running on the system, even if it's just running normal user, it's able to enumerate the webcam and detect that a legitimate session has occurred, and then can start recording off it. You can also always record, even if the user is simply broadcasting. Like, I never record myself when I use my webcam. I'm just broadcasting myself to remote people, basically. But again, the operating system doesn't differentiate between broadcasting and recording. So the malware can record off the webcam even though the user is simply broadcasting themselves. And then again, since the LED indicator light is already in use, there's no secondary indication that some secondary process has jumped into this existing webcam session and is recording off the device. So as an avid Mac user, that kind of bummed me out. Like, I really wanted to know if some undetected malware on my system was performing this attack. And more simply, who was using the webcam. So there are some tools that can tell you when the webcam is activated. And not to knock those tools, but the light's going to come on as well. So the tool's going to pop up saying the webcam is activated, and you're like, yeah, the light went on as well. But these tools don't tell you who is using the webcam. If you've just started FaceTime, yeah, it's going to be FaceTime. But it might be one of these malware samples I mentioned that arbitrarily starts recording. So if you're sitting at your desk and all of a sudden the light pops on, it'd be nice to know what process, what task triggered that. And of course, these tools also don't tell you if there's any secondary processes that are jumping into the existing stream and recording off that. So I wanted to write a tool that would provide me this information. Basically, it would tell me whenever any process accessed the webcam, would tell me what or who that process was, and then if any secondary processes jumped in and piggybacked off that session, I wanted to know about that fact as well. So in 3 steps, it's pretty conceptually simple. The first thing we do is we can register for webcam notifications, just like the malware does. And then what we can do is we can identify the consumer process, that is the process that's using the webcam. And then while the webcam is in use, we can basically monitor the webcam to see if any secondary consumer processes are jumping in to piggyback off that session. So conceptually, this is what the tool is set to do. So I'm releasing the tool today. It's free. It's called Oversight. Now, I know there's some companies that say if a tool is free, you are the product and blah, blah, blah. But I selfishly wrote this tool to basically protect my Mac. Again, love my Mac. I've drank the apple juice. And I figured sharing is caring, so that's why I'm releasing it for free. It doesn't collect any information about the user, just does its thing. So what does Oversight do? So Oversight can detect when the internal microphone or webcam is activated, but more importantly, it can also identify who is using the webcam, the process that is, and then it can also tell you if anything's jumping in and secondarily piggybacking off that. So what it does is when it detects this, it'll generate an alert in the Mac notification and can allow the user to allow or block. I know some users are just going to click allow. That's a problem I don't think I'll ever solve. But it also logs this information to syslog. So in a corporate environment, a sysadmin could pull the syslogs and determine when the camera is being activated, when the mic is turned on. And so maybe reactively do some analysis on those logs to maybe detect some otherwise undetected malware, or maybe just see what employees are using the webcam. So under the hood, Oversight is designed in the following manner. There's 2 components. There's a login item and an XPC service. So the login item runs every time the user logs in, and it does a few things. First thing is it can display a status menu, which shows you the activated devices. So if the camera is active in the mic, it allows the user to configure the app, nothing too special there. And then it also monitors for audio and video changes using the methods we described earlier. And then it will generate alerts to the user because it's running in the desktop session, so it's able to display notifications to the user. The other piece is an authorized XPC service that's running as root. And the reason it needs to run as root is twofold. First, and we'll talk about this on the next slide, it is responsible for identifying the consumer process or processes, that is, detecting who or what is using the webcam. And then it also can kill the process. So if the user clicks block, the malware might be running as root. The login item is running as the user in the user session, so it doesn't necessarily have the correct privileges to kill that process. So if if the user clicks block, that just sends an XPC message to the service, and the XPC service will then terminate the application. So one of the main features of Oversight is its ability to find and identify the initial consumer process, but then subsequent ones as well. And this is, I think, is really the coolest feature of the utility. So it turns out this is really not, or wasn't trivial to do as far as I know. Like, I emailed Apple, I said, hey, I know the webcam is on, how do I find out who's using it? And they didn't have a good answer. And Stack Overflow, same thing. So I ended up chatting with some security researchers, Jonathan Levin, who wrote the OSX and iOS internals book, awesome guy, and another guy, Simon, from a company named Avecto. And they were both really super helpful and gave me some good ideas, so definitely want to give them some credit. So basically, the reason this all works is anytime a process goes and uses the webcam, under the hood, the frameworks send a mock message to the camera assistance process. Now, the camera assistant process is just an Apple daemon that's kind of running in the background. So what Oversight does is monitor that camera assistant process and simply sees who sends mock messages to this. Because again, every application, every process, every task that starts to use the webcam, even if the webcam is already in use, will send a mock message to that. Like, that's the Apple low-level APIs doing that, the frameworks. So now we have some candidate process. Turns out, though, that some other processes also send mock messages to that same camera assistant daemon. So we got to somehow filter out and post-process those so that we can correctly identify the consumer process. So what we can do is, once we get some candidate applications, for example, we see Skype sent a mock message and maybe another daemon, we can simply analyze those processes. So for example, we can see what libraries it's loaded, and also we can see thread backtraces to see if that application is actively monitoring or recording off the webcam. So again, this is not an exact science, but it's nice because it's all user mode. You don't have to use a kernel extension. And in all my testing, it's very, very accurate. All right, so speaking of free OSX tools, this is not a sales pitch because everything's free. I just wanted to briefly mention my personal Mac security website. I write a lot of Mac software, kind of like sysinternal stuff for Macs. We have Task Explorer. It's kind of like Process Explorer is on Windows. It can show you all running tasks, open files, network connections. But it can also show you all encrypted processes or packed files that are running on your system. Knock Knock is pretty much auto runs for Mac. Shows you everything that's persisting on your computer. Block is a utility that simply monitors those persistence locations. It's kind of like a firewall for those persistence locations. So if anything tries to persist, like all Mac malware, the user will get an alert saying, you know, process X, this Flash update you just downloaded from the internet is trying to persist the login item, and then they can block it. Ransomware is another free utility. It basically monitors the file system looking for the rapid creation of encrypted files by untrusted processes. Mac ransomware is not that sophisticated, so it can generically detect Mac ransomware really well. All right, so that's a wrap. Thank you so much for attending. I also want to thank Virus Bulletin for, again, putting on an incredible conference. We have 2 minutes, so if there's any questions, I will entertain those. Yes, in the back. Don't ask any hard ones.
Hi, it's been very interesting, but in terms of being an attack tool, it sounds like it's an extremely expensive way for an attacker to attack. Unless I'm missing something, it sounds like if you have a many-to-one, because it's got to send the file back somewhere. So if you have a many-to-one relationship, then you're going to have dozens of hours of video to sift through to look at what you're wanting. If it's a one-to-one attack, then you have to, 1, know the victim's using a Mac, 2, probably know when they're going to use it in like a business meeting, something that you're interested in, and get them to install the malware in the first place. Can you see where this could be scalable?
Yeah, definitely. I guess maybe my background has skewed what I think is possible and not. But I would argue that there's actually some benefits to this. So yes, the prerequisite is there has to be malware on the system. But we've seen there's a lot of Mac malware out there that gets onto the user's system. Once there's an infection, I kind of see this capability as a way to improve existing Mac malware, where the existing Mac malware is already webcam aware and will start recording the user arbitrarily, which, as you said, will generate hours and hours of video. Using this capability, the recording will only trigger when the user is actively using the webcam, which is probably what the malware simply wants to record as well. So basically, it's a way for existing Mac malware to improve its recording capabilities in a way that the LED indicator light doesn't go on as a direct result of the malware. So it's basically just a way to improve that. Does that make sense?
Okay, we're out of time.
Okay.
Patrick, first I want to thank you for writing Oversight and sharing your tools with us.
Oh, thank you.
Great presentation. Please join me in thanking him for his presentation.